All right, let's dive in. Today we're talking about one of the biggest shifts happening in software right now. We're moving way beyond simple apps and basic chatbots into building sophisticated AI systems that can actually think, reason, and most importantly, get things done.
So let's start with a really big question. What if your application wasn't just a passive tool you had to click around in, but was an active partner? You know, an assistant that could understand what you need, find the right information, use tools, and just complete the task for you. That's the future we're building, moving from static apps to these dynamic, agentic AI systems.
Okay, so before we build, we need to understand the fundamental problem we're trying to solve here. Because as powerful as standard large language models, LLMs are, they have a pretty major weakness.
Think about it like this. A standard LLM, on the left, is like a brilliant encyclopedia printed last year. The knowledge inside is incredible, but it's totally frozen in time. It has no idea what happened today, and it definitely can't access your company's private files. But an agentic system, that breaks out of the box. It can connect to the internet, use APIs, and work with live data to actually accomplish things. It's really the difference between a know-it-all and a do-it-all.
So how do we start building one of these more capable systems? Well, like any good construction project, it all starts with the foundation. And in AI, that foundation is data. To make an AI smarter, you first have to give it access to the right knowledge.
There's this timeless saying in computer science that has never been more relevant than it is right now with AI. Garbage in, garbage out. It's so simple, but so true. The quality of your AI's answers is 100% dependent on the quality of the data you feed it. If you ground it in high-quality, trusted information, you'll get reliable results. If you feed it junk, well, you get the idea. The process of getting all this data ready is called the ingestion pipeline, and it really boils down to 3 key steps. First, you connect your sources, all your databases, documents, knowledge bases, you name it. Second, you pre-process it all. This is a super crucial cleaning step to get the data AI ready. And finally, you generate embeddings. Now, this is where the magic really starts to happen, because this is where we translate human language into numbers that the AI can actually work with.
And that last step, embeddings, leads us directly to the AI's memory. See, once our data is all prepped, we need a really smart way to store it, and more importantly, to find things in it later. And that's where vectors come into play.
So what are vector embeddings? Well, the best way to think about them is like a massive, hyper-intelligent library. But instead of organizing books alphabetically by title, this library organizes them by concept and by meaning. So books about corporate finance and investment strategies are all on the same shelf, right next to each other, even if they don't share the exact same keywords. And this is what lets an AI search for the idea behind your question, not just the specific words you used.
And here's the really amazing part. This technology has become so accessible. You don't need some exotic, expensive, specialized database anymore. If you're using a totally standard database like Postgres, you can turn on these powerful vector capabilities with just one single line of code. It's incredible.
So how does the AI actually search this conceptual library? It uses something called a similarity search. Your question gets turned into its own vector, and then a simple SQL query, just like this one, finds the data vectors that are conceptually closest to your question's vector. In this case, it's grabbing the top 3 most relevant documents. It's basically using math to find the perfect piece of information.
Okay, so let's recap. We've given our AI a high-quality memory and a really smart way to search it. Now, let's connect all the pieces to build something that doesn't just answer questions, but can actually go out and perform tasks for us.
The first part of this puzzle is a technique called retrieval augmented generation, or just RAG for short. RAG is the bridge that connects the AI's memory, our vector database, to its brain, the LLM. So, before the AI even tries to answer you, the RAG system first retrieves the most relevant facts from your data. This is so important because it grounds the AI's response in truth and prevents it from making stuff up, or what we call hallucinating.
And now we level up from RAG to a full-blown AI agent. And the difference here is absolutely crucial. An agent isn't just a question-answering machine. It's an LLM that's been given a specific job to do. It has instructions, it has a goal, and critically, it has a set of tools, like the ability to call an API or browse the web, that it can use to accomplish that goal. It can actually act.
And when you look at how it's done in the code, it's actually beautifully simple. This one line shows you that an agent is really just defined by 2 core things. Its instructions, what's its purpose, and its tools, what can it actually do. This is how you transform a general-purpose model into a focused, specialized assistant. But what happens when a task is just too big or too complicated for a single agent to handle? Well, you do the same thing you do in the real world. You build a team. And this is the whole idea behind multi-agent systems.
Instead of trying to build one giant monolithic AI that's supposed to be an expert at everything, it's way more effective to create a team of specialist agents. Each one has a very specific, focused role. They work together in a structured workflow, passing the results from one to the next. It makes the entire system more powerful and way easier to manage. Here's a fantastic real-world example of how this works. Imagine a system that checks your software for security holes. The first agent, the scanner, has one simple job: read a file and list all the software components. It then hands that list to the analyzer agent, which uses an LLM like Gemini to check each one for known security issues. Then an alternatives agent, using a different model like GPT-4o that's great at coding, suggests secure replacements. And finally, a reporter agent takes all that information and writes up a clean, human-readable report. Each agent is a specialist, and together they get the job done perfectly.
So there you have it. We've gone through the whole journey, from starting with just raw data all the way up to a coordinated team of AI agents. And this really represents a fundamental shift in how we even think about building software.
So let's just quickly run through that recipe for building an agentic system one last time. It all starts with the foundation: high-quality data. We use vectors to give the AI a conceptual memory. RAG is the bridge that connects that memory to the AI's brain, giving it context. Agents are what give the AI hands, allowing it to use tools and take action. And finally, multi-agent systems let you build an entire team that can tackle incredibly complex problems.
And all of this leaves us with one final, really big question to think about. As these systems become more and more capable, more autonomous, and more deeply integrated into how we work, are we really just building apps anymore? Or are we now in the business of training a new class of digital employees ready to take on tasks we never thought a machine could handle?